part 6, binomial probability. When we're looking at binomial probability, it's important to realize that there are only 2 outcomes, right? That is what makes it binomial. Now, an easy way to kind of think about the 2 outcomes as being yes and no. Probability that yes, we got what we want, the probability no, we didn't get what we want, right? So what we're looking for is we're looking for a group of a certain number of successes out of a certain number of attempts. Now, notice that we have N, which is my total events. All right, how many events are taking place? There's a certain number. All right, R is how many yeses or how many successes. All right, how many times are we trying to get the thing we want? All right, P is just the probability of yes. What's the probability of getting that thing? All right, so what's the probability of the specific outcome we're looking for? How many times do we want it to occur? How many total events are taking place? Notice this probability is 1 minus P. All right, so once I know what the probability of yes is, I can just do 1 minus P, and that gives me what goes in this parentheses. And X exponent is N minus R, or you can think of it as once I've used this number of R, this is how many events are left out of the total. All right, let's look at a couple of examples. A common example for binomial probability is rolling a die. And we'll look at another common one, which is flipping a quarter. So for this one, what is the probability of rolling a die 15 times and having it land on the number 4 3 times? So this is the total number of events. This is how many successes I'm looking for. And success, or you can think of it as my yes is rolling a number 4. So the first thing I want to do is I want to find a group of 3 out of 15. All right, so we're going to use NCR. So this is the way it looks when I type it in the Desmos. I just go to function, stat, NCR, big number first, small number second. This times the probability of rolling a 4, which is 1 out of 6. How many 4s am I trying to roll? 3. This is the probability of not rolling a 4. We can do 1 minus 1/6, which gives me 5/6. All right, so that's the probability of not rolling a 4. There are 5 numbers that are not 4s on a die. If I only want 3 of them to be 4s, that means that 12 of them, 12 out of the 15, are not 4s. Now, important thing to remember is that these 2 numbers always equal the total number of events, and these 2 probabilities always equal 1. All right, so when I type that into Desmos, I find out that my probability of rolling 3 4s out of 15 rolls is approximately 0.236. If I convert that to a percentage, I've moved my decimal 2 units to the right, and I have 23.6%. So out of rolling a die 15 times, there's a pretty decent chance that 3 of those times will be a 4. My next example, let's say Bill has a batting average of .30. What is the probability that Bill will get a hit on 8 of his next at-bats? So here's my total number of events. This is how many events I'm looking for, and this is my probability of success, or my probability of yes. So we start off finding how many different groups there are of 8 out of 15. So this is 15, 8. All right, so the probability of Bill getting a hit is 0.3. So the probability of success is 0.3, and we want this to happen 8 times. The probability of failure is 1 minus 0.3, or 0.7. All right, and the number of times that he would not get hit is 7. All right, so once again, these two numbers add up to be 15. These two numbers add up to equal 1. Now, these two numbers don't always add up to be 15, but they add up to be whatever the total number of events is. All right, so when I type this in, just like this into Desmos, I find out that this probability is 0.035. If I convert it to a percentage, I move my decimal 2 units to the right, and that gives me 3.5%. So Bill has a 3.5% chance of getting 8 hits out of his next 15 at-bats. Find the probability of rolling 9 threes out of 12 rolls of a die. This time, I'm trying to roll significantly more successes out of the total number of rolls. All right, so I'm thinking right now my probability might be smaller. I don't know how much smaller. So 12 is the total number of rolls, 9 is the number of successes, and 3s is what I'm trying to roll. So once again, I have NCR 12, 9. I'm trying to make a group of 9 out of 12 total rolls. The probability of success is 1/6, and I'm trying to have 9 successes. The probability of failure is 5/6, so when I do 1 minus 1/6, it equals 5/6, and there would be 3 failures. These two numbers add up to equal 12. These two numbers add up to equal 1. All right, when I multiply, when I type this in the Desmos the way it looks, I get 0.0001263. Notice that is very small, much smaller than the probability of rolling 3 4s. All right, for this example, find the probability of flipping a heads on a coin 22 out of 30 times. Now, when we look at a coin, the probability is 1/2. There's only 2 sides, heads or tails. So I'm gonna do NCR 30, 22 times the probability of landing on heads is 1/2. The probability, or the number of successes I'm looking for, is 22. Notice that the probability of failures is 1/2. All right, once again, 1 minus 1/2 gives me 1/2, and this is 1 minus P. And there are 8 to the left. So 8 and 22 adds up to be the total number of events. These two probabilities add up to be 1/2. When I type it into Desmos, just the way it looks right here, I end up with 0.0054. So the probability of flipping 22 out of 30, the probability of flipping heads 22 out of 30 times is relatively small, but it is better than rolling a die 12 times and having 9 of them be what you're trying to roll.